Matrices are an important part in terms of that they can solve systems of equations, as well as they could also work with geometry in terms of reflections and rotations and all of that good kind of stuff. But before we get into that, you first need to know what a matrix is, as well as how it's defined and all of that good information. So a matrix is just an inventory of numbers. Okay, so I'm just going to give you an example here. Let's say I've got 3, 2, 1, negative 4, 0, and 2. Okay, so these numbers that are individually placed, these are what we call elements. We obviously have our rows, and we have our columns. A matrix is defined by our rows and then columns. So the matrix name, in this case, would be, again, rows by columns. So we'd have 3 by 2. And that's because we have 3 rows and 2 columns. Okay. The other thing is you will have what's known as a square matrix. A square matrix obviously needs to have the same number of rows as well as the same number of columns. With this, you will be asked to find the dimensions of your matrix as well as locate any type of element. So for instance, if I were to ask you what is the element 1, it would be row 3, column 1. That's its position. The other thing is talking about the geometry. So let's say that I have a triangle. Sorry, I'm just kind of making this short. I can list this triangle in terms of its points, and this is what we call a point matrix. So this is a matrix located on the coordinate plane. So for instance, this triangle is going to be denoted, and I always list my points to make it a little bit easier to visualize here. Your x coordinate goes in the top, your y goes in the bottom in terms of your rows. So point A would be located at 0, 0. Point B is located at 3, 0. And point C is located at 2, negative 2. So based on this matrix, I should be able to, if I didn't have the graph and I had just the point matrix, I could graph this based on that point matrix. And it really doesn't matter if you have a triangle or a square or, you know, any other type of polygon that you have, just so long as you know that it's x above y. The other thing to look at is what we call scalar multiplication. This is pretty basic. Let's say that I've got 3 on the outside of this matrix, 4, 2, 1, negative 3, 0, 1. So if I were to actually look at this, I want to find what my new matrix would be after my scalar multiplication. A scalar multiplication means that you have a number that's on the outside, like our 3, and we're just multiplying everything by 3, every element by 3. So this is pretty straightforward. 4 times 3 gives you the 12. 3 times 2 gives you 6. 3 times 1 gives you 3. 3 times -3 gives you -9. 0, 3. So this is your scalar multiplication. Like I said, pretty straightforward. But the dimensions, make sure you know how to find the dimensions, as this is very, it's imperative for what's coming up in terms of addition, multiplication of matrices, and all of that good information.